Okay, so in this video I want to demonstrate how you can discover and exploit a deserialization vulnerability. In this case I'm going to use an old vulnerable version of JBoss to demonstrate this. So I've got here opened in my browser the JBoss instance that I found. I've got my traffic proxying through Burp Suite. So you can see here the JBoss traffic in the Burp Suite proxy history. Now I know that JBoss has an endpoint that's vulnerable to deserialization, but a good way of discovering that this is a possibility, especially in Java applications, is to look for deserialized objects being either sent to or returned from a web server. So here's the URL that I just browsed to, and we can see that in the response we've got this serialized object here being returned, which gives us a clue that maybe this endpoint is vulnerable to a deserialization vulnerability. So what I'm going to do is I'm going to send it first of all to repeater, and in the repeater I'm going to change the type of request to post. I'm going to give it some content just to check that it still seems to work. So I'm still getting a response here with a serialized object in, so it may be that I can then send a malicious serialized object in the body here. So let's find out. So this request I'm now going to send to the deserialization scanner burp extension. So this extension basically helps me to test for and exploit Java deserialization vulnerabilities. I have to make sure that I've downloaded Serial and that I've told this extension where I've downloaded it to. So here's the request I want to test. So I select the insertion point, which is, I'm just going to choose the whole body of the request, and select set insertion point, and then click attack. Now what this extension is now doing is it's now trying to send a number of different types of serialized objects with malicious payloads, in this case, or pseudo malicious payloads. In this case, the payload will just cause the Java instance running behind JBoss to sleep for a certain number of seconds. And that means that if the deserialization scanner that we're using here sees that the request is delayed by that number of seconds, then it seems like it will be vulnerable to other malicious serialized objects. The important point to note here is that deserialization scanner is creating payloads to run at the Java level. So they're not running at the operating system level, they're running at the Java level. If we then go on and exploit Serial, the tool that we use to create our exploit payloads, is generating payloads for the operating system level. So if we were to generate operating system sleep, we wouldn't see the same result, because the operating system sleep would happen in the background and a request would return, or rather a response would return straight away. So it's important to understand that distinction. At this stage, at the manual testing stage, we are seeing the scanner use a malicious payload at the Java level, whereas now when we go to exploit it, we're going to be running payloads at the operating system level. So the scanner's come back and told us that there are a number of potential ways in which this might be vulnerable, this endpoint might be vulnerable. So we're now going to send our potentially vulnerable request to the exploitation tab. So in this tab we're now going to try and run an operating system command to prove that we can run commands at the operating system, we can run shell commands. So what I'm going to do, I'm putting in a operating system level command here, which downloads a web shell from my GitHub repository and deploys it onto this web server. If we go to the directory of that web shell, we can see that right now that doesn't exist. So let's see what happens if we now exploit this deserialization vulnerability using this operating system commands to download and deploy the web shell. So we don't see any obvious result from the exploitation window here, but let's see what happens when we now go to web shell in our browser. So whereas previously we were getting an error, now we can see that the web shell has been deployed. I can run I can see this is a Debian server. I can run the id command and see that I'm running as root. I could also run a command to see the contents of the directory where we deployed our web shell to. So what we can see here is that we now have operating system level access to the server hosting the JBoss instance. We can now progress that and start using that as a foothold to exploit other machines within the same network. So hopefully that's given a good example of how to test for and exploit a deserialization vulnerability and why it's so dangerous.